Hello, welcome to the course Electronic System Design. Last few lectures we are discussing about the KiCad software. We saw the workflow of KiCad software, what are the various steps we do, and then we saw different modules available in the KiCad. For example, we have schematic editor where we can create schematic. For that we need symbols of all of our devices, so we saw the symbol editor. Then we go for the PCB editor where we design the PCB. For PCB editor, then first thing we need is footprint of all the device, so we have a footprint editor separately. Then we saw some additional modules. For example, we had calculator app, which is very useful for figuring out how much the track thickness should be there, what will be the impedance of the line what we draw at high frequencies. So we saw all these different modules. Today we are going to discuss the step-by-step process of how do we create a schematic in the KiCad software. This is important because once we are fluent in these steps, that first we need to do this, then this, then this. So if we know the process of schematic creation, then we can go for actual circuit, whatever we intend to make. It will be easy and faster to make that schematic in the schematic editor. So today we are going to discuss the schematic editor step by step process. How do we start? How do we put the components together, and what are all the steps we take in completing a finished schematic. So let's go to the slides. So to start any project in the KiCad, we go first to the file, which is the menu on the top of the software. So we go first the file, and then we create a new schematic. Or board. So this is done by selecting new project. So there is some option called new project, which can directly create schematic and board. So once we click on the new project, there are two files which comes up in this project file window. Here you will have one schematic file and one board file or PCB file, whatever we want to call it, and the symbol will be something like this for that schematic file, and for PCB it will be something like this green color option. So these will be automatically created once you create a new project. You can give your desired file name and that project will be made here. So you can see all those files. So for this you can actually browse to your desired location and give your project a name wherever you want to save it. So you need to browse to your desired location and give your project a name. So whatever name you give, that one folder will be created in your desired location. Inside that folder you will find this schematic file and a board file. So this schematic, as the name says, this is for the schematic preparation, and this board file is for the PCB manufacturing. So the the very first step we do for making a PCB is we create a schematic that we do in the schematic editor. However, even before, once we finalize the circuit, that we do in other software, some LT Spice or other software, where we find out the exact circuit what we want to implement, and that same circuit we want to make in the schematic editor. For Spice, generally people do not prefer KiCad. So, Spice level simulations many of the people do in the other software like LT Spice. Once the circuit is fine, it is meeting the specifications, that circuit is imported or it is made in the schematic editor. So, today we are going to see how do we create a complete schematic which is ready to port to the PCB editor. So, today we are going to discuss the schematic editor in detail. So, after opening this project, we click on schematic editor on this symbol, or we can double click on this schematic file which will directly open the schematic editor. So, once we click on this schematic editor, the first thing KiCad should know is your symbol library. Means where all the symbols available, whatever device you are going to use in your schematic. So, it will ask you first where is the symbol library table. So, this window will pop up. It may open only on the first time when you start KiCad on the very first time. So, this is your symbol library table setup. So, this is a step where we are telling the KiCad software that all the symbols are available in a library, and that library is at that particular location. So, for example, when this dialog box will open, we want to copy the default global symbol whatever is available in the library table. That is also even recommended by the software, so that you can directly import. You just click OK, and if for example the software is not able to locate this file automatically, or your installation directory is something different, then KiCad does not have direct path. These paths are standard in your operating system. For example, in Windows system, you have this in the C drive, there is a program files folder. Inside that KiCad 6 or 7, that can be the version of your KiCad. If it is 6, then it is 6.0. If it is 7, then 7.0. Inside that, in this you will have your library file. For Linux, we have this option, and for the Mac OS, we have different paths. So, at this step, we are telling KiCad that all of our symbols, what we are intended to use in our schematic preparation, they are available at this path, and we want to copy those default global symbols. We do not want to change any of the symbol for time being, and then click OK. So, the very first time the schematic editor is open, this dialog box will open. So, the very first time the schematic editor is opened, a dialog box will appear asking how to configure the global symbol library. And these are the standard paths based on the operating system. Once we specify the path that these are the symbols library available at this path and we want to create a schematic using all these symbols, the next information KiCad wants from us is what should be our schematic sheet setup, like what should be the width and length of our schematic where we want to make our schematic, what is the width and length typically, and how much is the workspace or how much is the area KiCad should offer us to create our schematic. So the next option is schematic sheet setup. In this setup, we are telling KiCad that this is the size of my work area where we want to create this schematic. For example, this is the standard size, or we can have this drop down menu, click on it and it will show various sizes, for example A4 or any standard size, or even we can put the extra dimensions whatever we desire here, so that that much size of the schematic will be created for our schematic preparation. This is the orientation. For example, we have landscape mode or in the portrait mode, so that we can specify here. These are some other options which are available to us. For example, we can give the title, let's say getting started in KiCad 6.0 or 6.1, whatever. The revision, we can mark it whether we are doing it the first time or this is kind of a upgradation on the very first board. So this is just for our information. This information is nothing to do with the production quality or the any simulation error or any kind of simulation we do. This is just for our information. So all these options, these are just for the information. and they do not impact any functionality of the schematic or PCB we are going to create. This sheet we can invoke by going to File, and then there is a option Page Settings. Go to File and then Page Settings. And these options, like this title block, is for the information purpose. However, this is very good option which we want to keep track on. So once we make a PCB, sometime it's possible that that PCB has some error, it's not working as per our desired functionality. Then we go back again to the schematic, create or make some changes in the schematic and make the PCB again. So that time we want to have some kind of a version control. So this is very easy to do in the revision, where you can mark this as 0, 1, 2 or any number, which shows that we have created this schematic earlier, and this is the update on the previously created schematic. So now KiCad has the size of our schematic and what is the orientation of our schematic is going to be. Then now the next step in creating the schematic is adding symbols to the schematic. So once we do this OK, that this kind of workspace will be created. This is a sample sheet created here for our schematic creation. So this is the schematic window, we can call it. This is the window where we are going to create all the schematics. So here this is just the preview. Once we click on this OK, this sheet will come in the full screen mode. So we have enough space to draw the schematic. So the very first step in creating the schematic is we need to bring all the components into the schematic window, whatever we want to use for circuit preparation. So that step is adding symbols to the schematic. So the next step is adding symbols So in this step, we are collecting all the symbols of components. For example, we want one resistor, one inductor, one capacitor, one transistor. So all these components, what we are intending to use in our circuit, we need to bring the symbols of those components into the schematic sheet. So that we can bring out by clicking a add a symbol button is there on the schematic window, which we have already discussed. So we need to click on this and this dialog box will open. So we start making the circuit. by adding desired symbols to the schematic. This we do by clicking the add a symbol button. Or just by pressing the A. So this is a shortcut to invoke the choose symbol dialog box. If you press A or press on the add a symbol button, this dialog box will open. Now if we see closely this choose symbol dialog box, it has hundreds or even thousands of components available here which we can use in our schematic. This is a large grouping where we see this LED. This is a grouping of all the LED we have. Inside this, if we click on this, we have so many LEDs available in this group. We can choose any of it for our adding into the schematic. So this is the short description of what that component is, and we have so many components available for our schematic. So it's easy actually to search here using this search option. We can write simply R and it will show up all the resistance values, or if we simply choose, we write L and press enter, then all the inductor values will be shown here. We can pick any of the inductor symbol by clicking on it. A short description is there in on the this below window. It says that the name is LED, which is light emitting diode. Keywords are LED diode. The reference value is still a variable which is mentioned by this question mark. The footprint is still not associated to this. This is also shown here as on the right side. It says no footprint specified. It means if we have this symbol, we can use this component in our schematic and generate our complete schematic. We can pass all the electrical rule checks. However, we cannot proceed to the PCB design because there is no footprint available for this particular LED, whatever component we want to use. So here if the value is not specified, it means it is not still associated to any footprint. You have two options. One is you create your own footprint if you desired so. If it is a new type of device, you would like to create your footprint and mention here. We will see that how that we can mention it. Or you can attach an existing footprint from the footprint editor to this component, and then that path will come here. At that time it will show the footprint attached to this symbol. Data sheet is also not attached to this symbol. So this is one typical symbol which we are going to use and learn how to use this to make a complete PCB. This is the symbol of LED what we are intending to use in our schematic. So once we click on this LED, this symbol will open up. This is the symbol and this is the PCB or the footprint. If there is a footprint attached, that will be shown here. So once we pick up our component, let's say this, we have one LED, we choose this LED particular symbol, we click on this OK, then this will be added to our schematic window, which looks something like this. So this is our schematic window. Schematic window or schematic sheet, whatever we want to call it. We bring all the components by pressing A or add a symbol button. First we have choose here one LED. Next we have choose one resistance. This is the resistance symbol, and we are using a battery cell, which can be a coin battery or something. So that symbol we are using. So we want to make a circuit, very small circuit, using only these three elements, where this battery is providing power to LED, and this LED should glow. This resistance is a current limiting resistance, which should be in series of the LED to limit the current through LED. So only these three components we want to create a schematic. So after putting these components, we arrange these symbols so that this look bit neater and make a circuit comfortably. So the next step is selecting and moving objects. So we have first selected all these objects. For example, this is battery, this is LED, and this is our current limiting resistance. Now we want to arrange it properly so that it look like a circuit mesh. So we need to move these objects, and also we need to sometime rotate these objects as well. For example, this LED, the orientation is one terminal this side and one terminal this side. However, we want the terminal on the top and bottom. So we need to move this object. That move we can do by clicking on the move button or simply by pressing M. We can move this symbol. We just click on this symbol, press M, and then we can move it anywhere in the schematic window. And to rotate it, we have button there, dedicated button, or by simply pressing the R. If we click on this object, press the R, it will rotate. So we can rotate to any orientation, whatever is comfortable for the schematic design. So this is how we rotate the objects. So selected objects are moved by pressing M, and rotated by pressing R. So now we have collected all our components in our schematic window and arranged them properly wherever we want to put these components together. Now we want to make the complete circuit using these components. So we need to connect them through electrical wire. So the next step to this is wiring the schematic. In this step, we have arranged already our devices where we want to make a circuit. Now this, for example, the positive terminal of this battery need to be connected to the one terminal of resistance. For example, this is the terminology we are following. This is the resistance. The top terminal should be connected to the battery positive terminal. That we can do by simply pressing W. So that will add a wire wherever we have our cursor is. We point our cursor to this point, click on this point and press W, and one wire will start coming along our cursor. So we route it like this. We go here, click on this point and then click on this point. So once we start from one terminal and end to another terminal, automatically one wire will be connected between these two terminals. So this wire we can invoke by simply add a wire button. It is there on the left side of the toolbar, or we can simply write, we have some shortcut for this as well. So we can click the add a wire button. On the right hand toolbar. So once we draw a wire from one terminal to another terminal, it means these terminals are connected using a resistance or using a connection. Similarly, we can draw another wire from this negative terminal to the one terminal of LED, and these two terminals, one terminal of resistance and one terminal of LED, also need to be connected. Now the next step is we need to provide the ground terminal and the supply terminal to our circuit. This we can do by add a VCC symbol and ground symbol and connect them to the circuit with wires. So we need to add a VCC symbol and GND symbol and connect them to circuit also. Sometime when we make these circuits, we are interested in particular terminal or terminal voltages on the or the wire voltages. For example, this is a node in the circuit. This node is formed by the negative terminal of resistance and this terminal, let us say positive terminal of LED. So, this node voltages I am sometime more interested. So, I want to give it a name so that it is easy to interpret where I need to look the waveform. So, that name I can give to any particular net by net label button. It is there again on the right hand toolbar. I just simply click on that net label and it will ask for the name. I can give it any name for my information, which is straightforward, easy to understand. This node, for example, we are giving a name LED. So, this is only for the naming, easy to interpret. So, we click on net label button and name LED. To the net. So, when we create these schematic, wherever we have a node formed by joining two components or more, that node is already given certain name automatically by KiCad. However, if we want to put a desired name, we can always overwrite that by this net label symbol and we can specify our own name. So, when we generate the schematic net list, all the nodes, all the wires we have in the schematic, they will be given some random name NC001 or it may be a random number. The desired nets where I have put net label, that will be always called whatever we have given the name. So, LED is a name of this wire. This anywhere this terminal will be connected to LED waveform. However, this is very important to note here is, if I have a wire which I give the name LED here, it means this wire I want to call LED. Now, in a bigger circuit, if somewhere at the other place I am using one more wire and I give the same name to that wire also, LED for example, in this case there is another circuit. For example, just we are making one resistance here, one capacitance here and some voltage source for example here. So, this node for example, I mistakenly give it a name LED. It tells KiCad that this wire and this wire both having the same name. It means even there is no physical interconnection we see from this point to this point. We do not see any physical connection, but we are telling KiCad to connect these two nodes internally, this LED and this LED, which may create problems sometime because we have mistakenly given the same name to the two nodes, and if two wires are given the same name, they are assumed to be connected to each other, even though we do not see a direct green path. We do not see a direct green path from this node to this node. Even if we do not have this, Still, we are connecting these two nodes internally. So, labels with same name are connected together. This is very important point. This is used for making the schematic more readable, to so that we do not have so many wires going along from left to right. We just simply name them same, and we do not need to lay down a wire in the schematic to have them connected. However, if it is not desired, to connect those nodes together and we mistakenly join them together, this is going to create the error in your functional results. We are expecting something else, but because of this misconnection, our circuit will behave differently. So this is very good option, but sometime it creates problems, so we need to understand this carefully. The next is we need to do annotation. So each symbol need a unique reference. For example, in the last slide we have this, a general naming, these BT question marks. So we have not put a unique identifier to these symbols, so that we do in the annotation step. So we do annotation. Here each symbol needs a unique reference. So we just simply click annotate, and choose the default setting. So by choosing default setting, KiCad will automatically assign some reference to these devices. However, if you want your particular name, you can always change in the annotation stage. Then we have the symbol properties. We need to fill in the values for each component. For example, the lithium coil cell battery, This is the battery we used in our schematic. We want to specify a value of 3 volt to this battery. The resistance we want to change it to 1 kilo ohm, and LED has its own properties. So in the symbol properties we can edit the values whatever they have. If we have a battery we can specify the voltage, or resistance, capacitance we can specify resistance and capacitance value. So once we do these symbol properties, now is the step to assign the symbol a particular footprint. As we discussed, without footprint we can create the schematic where we are taking the symbol, joining them to make a circuit. However, to make a PCB we need the actual footprint of that particular component. So this time we need to finalize what resistance we are going to use, the manufacturer of that resistance. We need to download their data sheet of that resistance. In that data sheet one footprint will be given in the data sheet. So accordingly we need to choose the footprint and we need to assign that footprint into the symbol properties. So the next step is the footprint assignment. So this footprint assignment, many a times this is already attached. So many symbols we pick from the library. They are already pre-assigned footprints. However, if there is no footprint available, we can always attach them to a different footprint. So in the middle we see the footprint assignment window. This window lists all the components we are using in our schematic. So here we are using one battery, one the LED, and one the resistance. These are all the 3 components we use till now in our schematic. So all of them will be visible here. This is the footprint library where we can go to that particular that element. For example, we want to attach a footprint to this resistance. So we go here, in the resistance we see all the resistance values. So these are the filtered footprints. We have so many footprints available to the resistance, and here we need to choose what should be the landing pattern or the footprint of our desired resistance. So if we have, for example, SMD resistance, then there will be a 4 by 6 SMD components on 3:2. It depends on what resistance you are going to choose. Based on that you can choose the footprint and you can select it here. That path or that particular footprint will be assigned to your resistance symbol. So this is how we can attach footprint to each and every symbol. So we have these 3 components, these 3 symbols. So we need to attach 3 footprint, one to this, one to this, and one to this. So all of our symbols which we are using need to be attached a particular footprint from this footprint assignment box. All symbols need to be attached to one or their respective footprint. So once we attach these footprints, our schematic is ready, where we have made all the connections between the devices and we have attached the footprint. So the final step in that schematic creation is now checking the electrical rules, whether we are having any error or warning in our schematic. So that we can do by ERC, or the electrical rule check. This is called ERC in short. To do this, we go to the schematic setup and electrical rule check. There is a button already there on the top, so you can click on that ERC and run this ERC by clicking on this run ERC. It will run some general electrical rules on the schematic and find out if there is any error or not. If this is clean, it does not appear anything here in this window, it means our electrical rule check has passed and there is no electrical error in the schematic. If it shows some error, we need to find out what it is. So here this is just for the example, it does not mean what schematic we had designed earlier. It has an error. Here it is shown that this is how the error look like if there is any error in the schematic. So we just click on this error and it will point us in the schematic window where this error actually is. So it's a good idea to always run ERC before starting layout. So once we run this ERC and we do not have any error, then we can proceed to the actual PCB fabrication. However, we want to find out all the devices whatever we are using in our schematic, because we need to procure them from the market. So we need a list of all the components we need, that we can download by using bill of material. So that is a separate step which is used for making a sheet what we want to buy from the market to actually make the PCB. So this is the point. From ERC we can proceed for PCB design. However, in parallel we download the bill of material to procure all the components which we want to put on PCB from the market. So this is bill of material. Or sometime in short this is called BOM, the bill of material. To do this we need to go to tools and then generate BOM. So by clicking on this generate, we generate a complete CSV file. We can give the name here, whatever name, example1 or so, we can give the name here, and this will going to generate all the list of devices and their specification, their manufacturers, the values. All these specifications will be created in this sheet, which is a comma separated Verilog or CSV file. You can open it and order all the materials whatever you need before starting the PCB design. So today we saw in the KiCad how do we systematically design a schematic. We start from the schematic editor, we take all the devices together on the window which is called schematic sheet. Size of that sheet we can specify, we connect them together, we move or rotate the components. Then we saw we have electrical rule check where we can find out common errors. However, electrical rule check can find out many kind of errors or warnings, but it does not mean it can capture all the possible mistakes what you can make in your design, schematic design, or later find out in the PCB. This is just a checker that you are not making common mistakes. For example, you are connecting 2-3 wires together with one is overlapping on the other and you have a misconnection between them. So some of the errors only this electrical rule check can find out. However, for exhaustive analysis we need to go back to our schematic or the LT spice based schematic where we have done the simulation, find out if there is any error. We need to correct that in the schematic editor. So once we have all the electrical rule check passed, there is no error in the ERC, then we go for the bill of material. We take this list and we order it from the market. We go to market and buy these components. In this BOM, all the specifications, all the values, all the footprints, everything is mentioned in this bill of material. Now the next step from this schematic is to create PCB, which we will discuss in the next lecture. So this is all for today. Thank you.